we will carry on probability to discuss the probability density function. Probability density function, we will explain this one through this example. So, probability density function. Okay, we have this example. The number of hours Nabila spends each day working in her garden is modeled by the continuous random variable x with probability density function f of x. This is f of x defined by probability distribution function, this one. So we have three requirements. Find the value of k, sketch the graph of f of x, and number 3, find the probability that Nabila will work between 2 and 5 hours in her garden on randomly selected day. So now, solution. The first part. Find the value of k. Okay, to find the value of k, we must use the fact that the area under the curve, because this one will represent a function, and it will be a curve. So if we graph this function, we can see that it is composed of two lines. So now, if I calculate the integration from minus infinity to infinity of f of x, this means we see it is only between the period in this range. It is only in between 0 and 3. It has a value of kx, and between 3 and 6 it has a value of k6 minus x. So, and it is 0 otherwise. So the integration of the function, it will be this part and this part, and we will ignore this one because it is 0. So f of x in the first part, it is kx, so it is kx, and the limit is between 0 and 3, so I'll put the limit 0 and 3. Then there is another range, this one, it is from 3 to 6. I'll put like this and use k6 minus x, and the limit is between 3 and 6. And this one will be ignored as is equal to 0. I will ignore this one. Now, okay, I'll evaluate the integration here. So for this one, the integration will be kx squared over 2, because this one is a constant, and it is from 0 to 3. And for this one, it will be 6kx minus kx squared over 2, and the limit is between 3 and 6. Plugging these values here, we will get, we see 9k over 2. If I plug 3 here, I'll get 9k over 2. If plug 0, it will be 0. So there is no need to write minus 0. Okay, plus. If I plug 3, so it will be here for this bracket, it is 6k multiplied by 6 minus k6 squared over 2, and this, now I plug 6. Now I'll deduct 3 plugged here. So it will be 6k minus k3 squared over 2. After mathematical manipulation, I'll get this one equals 9k. Okay. Now, this one, the probability, because the total probability for any event or any function, it will be 1. So I'll get this one equal to 1. 9k, this one, the integration over the whole range in of the density function must equal to 1. So 9k equal to 1. That means k is equal to 1 over 9. So I have just found k. Now, solution of part 2.